I'm going to do a little bit of a homework help here and kind of review of the quantum numbers. Before I get to the review of the quantum numbers, I'm just going to take the homework and push it aside and just review one more time what we mean when we're talking about the quantum numbers. We had 4 quantum numbers. They are N, which stands for energy level. And that one's pretty easy. It's just going to be the energy level that we're dealing with. So when we were doing our electron configuration, we would do like 1, S, 2. Well, the 1 stood for the energy level. And then we might go on to go 2, S, 2. Well, here's another energy level. So those big numbers are what we mean by energy levels. Those are the ones that are written along the side of the periodic table. So that's a pretty easy one. Now let's talk about L. L stands for angular, and I'm going to underline the R, or the L, so angular momentum. So when you see that, another way to think of this, or these are also called orbitals. And again, you could look at that L as meaning orbital. So when we're talking about the orbitals, we had 4 different kinds. We had an S orbital, we had a P orbital, a D orbital, and we had an F orbital. Actually, you know what? I'm going to write these in a different way so I have a little bit more space. So F, P, D, and F. So the S orbital, we did our orbital notation using one box. And we said in this orbital I can have an up arrow, or up electron, down electron, which talks about the spin. It's either up or it's down. For the p orbitals, we had 3 boxes. Because there are 6 electrons that can be in the p orbital. We have 3 that are spinning up. We have 3 that are spinning down. So we have 3 suborbitals in a p orbital. The d orbital has 5 suborbitals. 1, 2, 3, 4, 5. Because remember, in the d block, we can fit 10 electrons in that d block. So we have 5 that are spinning up. So 5 individual electrons spinning up, and we have 5 electrons that are spinning down. And that fills the d orbital. The f orbital is bigger. We actually have 7 suborbitals. That's 1, 2, 3, 4, 5, 6. Oops, need one more, 7. Which means it can hold a total of 14 electrons. We've got 7 of them that are spinning up. And we've got 7 of them that can spin down. And now that orbital is filled. So the angular momentum, or the orbitals, are the S, P, D, and F. Now, the numbers that we're going to use, the S, we're going to use the number to abbreviate S as being 0. P, we're going to give the number 1. D, we're going to give the number 2. And F, we're going to use the number 3. So if I'm talking about an L equals 1, I'm talking about the p orbital, which has 3 suborbitals. So now that takes care of N and L. Again, the orbitals are just going to be those numbers. Let's take a look at M sub L. Now, and that's going to refer to these little boxes that we've drawn. So when we have an S orbital, we only had 1 box, right? And we're going to say that that's 0. For a p orbital, we had 3 boxes. So we can tell them apart. We're going to call this box -1, this box 0, and this box +1. So this is my S orbital. Here's my p orbital and the 3 suborbitals in between them. I'll give myself a little more room. For the d, we had 5. Here's our D. Now, to number this, the middle one is going to get 0, -1, -2, and on the other side, we're going to have +1 and +2. And we're just using these numbers to tell which of these suborbitals we're talking about. The D has 5 suborbitals, P has 3 suborbitals, and the S only has 1 orbital, no suborbitals to it at all. The last one is F. F had 7. You can see up here we had 1, 2, 3, 4, 5, 6, 7. So the same thing, actually I'm going to take that F away because I'm going to need that room, I think. So I'm going to need 7 boxes. So we've got our 0, -1, -2, -3, +1, +2, and +3. Now I'm going to label them. And these were our F suborbitals. The last number, and that was our M sub L, and this is called, the last number we had was M sub S, and this is the easy one because this is just referring to whether those electrons are spinning up or spinning down. So if it's spinning up, we're going to say it has a positive 1/2 spin. If it's spinning down, we're going to say it has a negative 1/2 spin. So the M sub S is our spin. So now let's put together some of these, and I'll keep referring back to this diagram. For problems, you'll see that I actually will draw some of these parts just to help me make sure that I'm not losing track of electrons. So the first thing says, rate each step of quantum numbers for the electrons in the 3s orbital. Well, in the 3s orbital, we have 2 electrons, right? So we've got 2 in that S block. So I'm going to be writing the numbers for 2 electrons. Now I'm going to be doing their address, and I'm going to kind of use my drawings over here. The first one is easy. N will be equal to 3, because it's telling us what the energy level is. Now L, I need to go over here and look to see what is the number that I use for the S orbital, because that's what we're doing, the 3s. Well, S equals 0. So L is always going to be equal to 0 for these 2 electrons. The M sub L, going back over here and dropping down to this, well, in the S orbital, I only have one choice. So M sub L has to be this box right here. So that's going to be 0. And now I'm left with my next one, which is M sub S. Now, remember, there are 2 electrons. One could be spinning up and one could be spinning down. So I do have 2 options in this one. I could have a +1/2 or a -1/2. So it's going to be -1/2 or +1/2. So if I wanted to write these numbers, and I know I'm running out of room, I'm going to zoom in here a little bit. So the answer would be 3, 0, 0, -1/2, or 3, 0, 0, +1/2. And that's the answer I'd put a box around. So this would be the set of quantum numbers for the first electron, and this would be the set of quantum numbers for the second electron. Our next question says, write each set of quantum numbers for electrons in the 2p orbital. Well, I'm going to not refer back to that drawing quite so much. I may slide over to it, but let's just take a look at it. So N is going to equal the energy level, and it tells us that it's 2. L is going to mean which orbital do I have? Well, it's the p orbital. So I have to look to see which number does the p orbital is represented by the p orbital, and that's going to be the number 1. So that's going to get a 1. So all of these numbers are going to have in common that they're in the second energy level, they're in the p orbital, so they're all going to get the 2 and they're all going to get the number 1. Now let's go ahead and do m sub L. Well, m sub L for a p orbital could be -1, it could be 0, it could be +1. So I've got 3 different options for that. So m sub L could be -1, it could be 0, it could be +1. The last one is the spin, so m sub S, and again there's only 2 choices for that. So it could be +1/2 or -1/2. So there's all the choices for the numbers. So let's go ahead. We've got 6 different electrons because the 2p orbital can hold 6 of them. So here we go. Here's my first electron. So electron, we'll call that 1. Its numbers are going to be 2, 1, and I'm going to say this one has a -1 because my m sub L is going to be -1. And this one I'm going to say has a positive upspin. My next electron, electron 2, these would be the same because I'm in the second energy level. I'm in the p orbital. Now I'm going to say that this one is in that suborbital that is labeled as 0. I'm going to say this one also has a upspin. Here's electron number 3. Again, same energy level. It's in the p orbital, so I give it a 1. And now this one is in that last orbital, and it's going to be a +1. And I'm going to say this one also has an upspin. Now I'm going to do the last 3 electrons. So E4, same, I'm in the second energy level. I'm still in a p orbital, so I'm going to give it a 1. This time I'm going to say I'm back into the -1 suborbital, but this is the one where I've got the downspin. And I'm done with that one. Here's the 5th electron, second energy level, the p block. I'm in the 0 sublevel now, and again this one's going to have a downspin. My last electron will be number 6. I've got second energy level, the p block. I'm in the +1 suborbital, and I'm going to have again a downspin. So there's the addresses for all of these electrons. Another way to do this would be you could draw out your p orbitals, and I'll show you that in just a minute. So there's our quantum numbers for every electron that's in the 2p orbital. Let's take a look at the differences. So when I'm comparing this, in this group, these are what are different. In the next group, these are what are different. So each one of these electrons has a different address. This one says, write a configuration for the following. Now some of these are going to get a little long, but I'm also going to show you what I do to kind of draw some pictures for myself so I don't get lost. The first thing is easy. This is the N. Oops, let me change colors here. The first number is always going to be L. The first number is always going to be N. The second number is always L. This one is always going to be M sub L. And this one's always going to be M sub S. So I like to pull these apart. So I know the energy level is going to be 2. The L, the orbital, is 1. Sliding back over to my picture here, 1 is the p orbital. And I'll actually write down for myself. I'll write down that this is the p orbital. And then what I'll do is draw the 3 boxes. 1, 2, 3. And now I'm on to the M sub L, and I'm going to label these boxes. So this box is going to be 0, -1, +1. And then I'm going to start to place my electrons. So I'm going to put my up spin, up spin, up spin. And I need to have the down spin arrow in that 0 box. So down spin, and then the down spin in the 0 box, and that's where I stop. So for the number of electrons I've got in that p orbital, I have, this would be 2p, and I have 5 electrons in there. So that tells me where I need to stop. So to do this electron configuration, it's going to be 1s2, 2s2, 2p5. And that would be my electron configuration. Let's take a look at B. I'm in the 4th energy level. My L, or my orbital, is a 2. 2 is the D orbital. So I'm going to write down that that's D. And then I'm going to draw my pictures. So the D orbital has 5. Zero, -1, -2, +1, +2. Now, I'm going to stop when I have my down arrow in the 0 orbital, but I'm going to go ahead and start just putting them in. So I've got up arrow, up arrow, up arrow, up arrow, up arrow. Now I'm doing my down ones, and I know I'm going to stop in the 0 orbital. So down arrow, down arrow, down arrow, and then I stop. So now I'm going to count what I have. My energy level is 4. My orbital is D, and I'm going to count how many I have. I've got 2, 4, 6, 7, 8. So I've got a total of 8 electrons in that D orbital. And now I'm ready for my electron configuration. 1s2, 2s2, 2p6, 3s2, 3p6, continue over here, 4s2, 3d10, 4p6, and I continue down below, 4s2, and then, oops, I'm sorry, that should have been 5. That should be 5s2. And then finally my 4d8. So this whole thing would be the electron configuration for that quantum number. All right, let's do C here. I'm going to try to write this a little bit smaller here because I'm running out of space. So I know my energy level is a 5th energy level. My orbital is going to be the 3rd one. So going back to my drawing over here, 3 is going to equal the F orbital. And for the F orbital, I had 7 that I need to draw. So 3 is going to be F, and I need 7 boxes. 1, 2, 3, 4, 5, 6, 7. Now I'm going to number them. The middle one gets a 0, -1, -2, -3, +1, +2, +3. So now the box that I'm going to be mostly interested in is where I end, and I'm going to be ending in this box, and I want to have the negative spin, which means I first have to put in all my up spins. So 1, 2, 3, 4, 5, 6, 7. Those are all filled. Now I can go in with my down spins. Down, 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 and I'm going to stop at that +2 box right there. So gathering all these things up, this is going to be 5F13. So there's 5F13. So for the electron configuration, again, it's going to be really long. In fact, I think what I'm going to do is just erase this other box so that I've got more room to write this and write a little smaller. All right, so let's go ahead and finish this electron configuration. And And we're going to start from the beginning, and I think I've got enough space here. I'm just going to write really tiny, and we're going to stop at 5F13. So here we go. We're doing C. So it's going to start off as 1S2, 2S2, 2P6, then down to 3S2, over to 3P6, then down to 4S2, 3D10, remember that drops down, 4P6, and then we're going to go to 4P6, we're down to 5S2, dropping down to 4D10. I'm going to run out of space. I'm going to have to wrap this around. After 4D10, I go to 5P6. Then I go to 6S2. Then 4F14. Come back across to 6P. Oh, I'm sorry, I messed up there. It's going to come down back to 5D10. Then back over to 6P6. Finally, 7S2, then down to 5F13. Phew. Oops, let's make it a 13 like it should be. So we finally ended there. So the whole electron configuration is all of this. Wrap around, go back down to here, and we've got the whole thing, the whole shebang. All right, I'm going to do a little bit of erasing here, and then we'll come back and do this next little section. So this next part says, write the electron configuration, or write the configuration for the electron. So we've got our address here, and this one ends up being a little bit simpler. My dogs are playing in the background, so I may have to stop this video to stop them so you can hear me. All right, so let's tear apart this quantum number. So we've got our fourth energy level. Here's our fourth energy level. Our L is going to be 2, so remember S is 0, P is 1, 2 is D, so this is going to be a d orbital. The d orbital has 5 suborbitals, and their names are 0, -1, -2, +1, +2. So we're going to be looking at the box that's called -1, and we're going to want that plus 1/2 spin. So let's see how many electrons we end up with. So I'm going to start here, and I've got an up spin and an up spin, and I'm in that box, and I've got the plus 1/2, so that's as much as I've got. So this is going to be 4D2. And that's where I'm going to stop. So let's go ahead and put this all together. So we're going to go 1S2, 2S2, 2P6, 3S2, 3P6. Now I'm in the fourth energy level. 4S2, drop down to the 3D10, 4P6, 5S2, now I'm into the 4D, and it's going to be 4D2. So there's that electron configuration. Now this next one's a little tricky because it says the electron paired with the one that has the number 310 with a plus 1/2 spin. So let's tear this one apart. So we've got our third energy level. My L is a 1, so remember 0 is an s orbital. A 1 is a p orbital. The p orbital has 3 boxes. Their names are 0, -1, and +1. So let's see, I'm going to be looking at the box that is 0, and I'm going to want that first upspin electron. So when I fill this out, it's going to be upspin, up spin, I'm going to stop there. So what we're talking about here is the 3p2. So the electron we're talking about is the 3p2 electron, is this one's configuration. However, it says the one that's paired with it. Okay, so we're going to keep on going here and figure out which electron is paired with it. So here's my next electron. Now I've got a down one and now a down one. So the one that's paired with the one that's referred to in the quantum numbers is going to be the 5th electron. So the one that we really want is the 3p5, because that's the one that's going to be in the same box as the 3p2, if that makes any sense. So let's go ahead and do this electron configuration. 1s2, 2s2, 2p6, 3s2, and 3p5 is going to be the one that's paired with the one that's described in these quantum numbers. So that is the answer for this configuration. That's a tricky question. Now let's shorten things up a bit and let's do noble gas abbreviations. Now remember, in the noble gas abbreviation, you're going to grab the noble gas, which is in that last column on the periodic table. You're going to put it in a bracket, and then we're just going to continue our electron configuration from there. So the first thing I have to do is figure out which one am I talking about here. So I'm going to tear this apart. We're in the 3rd energy level. The L is a 1, 0 is an s orbital, 1 is a p orbital. P orbitals have 3 boxes. Their names are 0, -1, +1. Now the box we're going to be really looking at here is we're going to be looking at this -1 box, and this time I want the negative spin. So let's count this out. Up spin, up spin, up spin, down spin, and that's the one that I want. So the last part of this electron configuration is going to be 3p, and I've got 4 electrons in there, so 3p4. So the noble gas, when I'm looking at this one, I'm looking at my 3rd energy level. So I'm going to look at the end of the 2nd energy level, and that gives me neon. So to do this, I'm going to put neon. Just put the symbol for neon, and then I'm going to continue my electron configuration from there. So from neon, I'm going to drop down to 3s2, and then 3p4, and that's the answer. Nice and short. So we've got an atom with 5 electrons in the 3rd energy level. So we got to count this one out. So we're in the 3rd energy level, and it's got 5 electrons. So I'm not even going to do boxes here. I'm just going to count out across the 3rd energy level. So the first thing is I have to get the noble gas. So that's going to be neon, because that's in energy level 2. So I'm going to get the one that's above it. And then I'm just going to continue my electron configuration, and it would be 3s2. The next orbital will be 3p, and I want 5 electrons, so that's going to be 3p3. 2 plus 3 is going to be 5 electrons. So I've got 5 electrons in the 3rd energy level. So this would be my final answer. Gallium. So I'm going to look at my periodic table. I'm going to find gallium. And there it is. It's over in the column number 13, kind of right at the edge of the D block there. There's 31 individual electrons. And I'm going to use the noble gas that's above it. So I'm going to go, it's in the 4th energy level. So I'm going to get the noble gas from the 3rd energy level, which is argon. Now I'm just going to, whoops, I should have done that differently. It needs a lowercase r. Oh, there we go. So now I'm going to continue my electron configuration. So I'm going to go to the 4th energy level, 4s2, go straight across, drop down to 3d10, and I'm going across there, 3d10, and now I'm back up into 4p8, and there's gallium, so it's 4p1. Potassium. Again, I'm going to find out where potassium is. It's in the 4th energy level. I'm going to grab the noble gas from the 3rd energy level, and it's argon again. Then continue my electron configuration, which is really short for this one because it's the very next one we're doing. So it's going to be 4s1, and I'm at potassium. Now for this one. Again, I got to tear these apart a little bit. I got the 3rd energy level. My L equals 1, and I know that a 0 would mean the s orbital. A 1 equals the p orbital. There are 3 suborbitals named 0, -1, +1. Now, I'm going to be looking at this box here, and I'm going to be stopping with that down arrow. So let me draw in so we've got up arrow, up arrow, up arrow, down arrow, down arrow. So my thing is going to be 3p, and I've got a total of 5, so 3p5. So now I'm going to I'm in the 3rd energy level, so I need the noble gas from the 2nd energy level, which is going to be neon. And then just continue my electron configuration. 3s2, 3p5, and I'm done. All right, give yourself a break. If you've been listening to this video the whole time, you've just spent half an hour listening to me go on and on about chemistry. Hopefully you kind of sped through some of this. Give yourself a break right now. I'm going to turn the page, and I'm going to do the back side too, which honestly isn't too bad. I think the front side is worse. Hopefully you gave yourself a good old hot chocolate break. We're going to name the elements. So some of these are very easy because we can just look at our periodic table. The first one is 4F3. So all I have to do is find the 4F block on the periodic table, which is that little subset that's down below it, and count to 3. 1, 2, 3, and that gives me PR. And that's my answer. Just look in the F block, 4th energy level, look for that 3rd element, and there you have it. Here's the next one. This one I have to tear apart a little bit. So we're going to be in the 3rd energy level, and we've got a 2 for our L. So 0 is S, 1 is P, 2 is D, so I've got a D. Now in the D, I've got 5 suborbitals, so I'm going to go ahead and draw them out. And I'm going to name them 0, -1, -2, +1, +2. Now, the one I'm going to be looking at and focusing on is going to be that +2 box. And I'm going to be looking at my down spin electron. So let me go ahead and put them in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is going to be 3D10. So now all I'm going to do is I'm going to look on this periodic table here and figure out which is the element that is in 3D10, and that one is going to be zinc. 3D10 is going to be the element. All right, let's do the next one, 4P3. That's an easy one. All I have to do is go to the 4th energy level, go over to the P block, count over 3, and that's going to be AS. All right, another one I've got to tear apart. We're in the 3rd energy level. L is 1, so 0 is S, 1 is P. P has 3 suborbitals. 0, -1, +1. So the one I'm going to be kind of focused on is this one here, and I'm going to be looking for that up spin. So let me go ahead and place my electrons up, up, and I'm good. So this is going to be 3p2. Use my periodic table, look across, and 3p2 is going to be Si. And that's going to be the answer for this one. All right, so here we've got some numbers that are kind of all scrambled up. So let me just put them in the order that would make a little bit more sense. So our energy level is going to be 4. So there I've taken care of that. My L is 2. So 0 is an S, 1 is a P, D is 2, so we're going to be D. Now M sub L, now remember the D has 5 suborbitals. 0, -1, -2, +1, +2. Now, the one I'm really interested in is that second one. So I'm going to put a little box around that. And I also want that up spin arrow. So now I'm going to place mine up, 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 up. So it's going to be 4D5. Looking on my periodic table, I'm going down to the 4D. Remember, it's going to be in that 5th energy level because it drops down. And I'm going to go 1, 2, 3, 4, 5, and that's going to give me TC. Is going to be the element I'm looking for. All right, let's take a look here. It says, explain briefly why each set of the following is not a possible set of quantum numbers for an electron in an atom. In each case, change the incorrect value or values to make the set valid. All right, so let's take a look at this. So if we have an N, second energy level, 2 is the D. Do we have any D orbitals in the second energy level? We don't. So that's a mistake right there. So I could change this to a 1, and that would make this a P. There is a P orbital. Let's see if that works. So we have 2. If we have 2, 1, we do have a 0. And we could have a upspin. So now that would be a quantum number that can exist. Let's take a look at the next one. We're in the second energy level. Our L tells us we've got a p orbital. That looks good because the second energy level does have a p orbital. And then I'm going to look at this part here. There's 3 p orbitals, and there is a -1, so I can have a -1 as my number. Now, the spin is never a 0. A spin is either +1/2 or -1/2. So my numbers could be 2, the 1 works, -1 works, but I'd have to have a +1/2 or a -1/2. Either one would be a number that would work. Let's take a look at this next one. We're in the third energy level. Our L is equal to 1, so that's a p orbital, and yep, the third energy level does have a p orbital. Now, p orbitals, does it have a +2? Remember, there's only 3 of them. 0, -1, and +1. Well, there's no +2, so let's just change that to, let's just change it to a 1. So I can have the p orbital, and I can have the number 1, and that +1/2 looks fine. So let's rewrite this. So we could have a 3. The 1 is fine. We have to change the 2 to a 1 because there's no such thing as a +2 orbital. And then we're okay with that +1/2. So that works. Coming down the home stretch here. The last one, what's the maximum number of electrons that can be identified with each of the following sets of quantum numbers? In some cases, the answer may be none. So it tells us n is equal to 3. So in the third energy level, I can have 3s2, 3p6, and I can have 3d10. So that gives me a total of 18. I can have a total of 18 electrons in the third energy level. Let's take a look at the next one. So in this case, we've got 3 third energy level. Our L equals 2, so that's the D block. So it's asking how many electrons are in 3D. Well, there's a total of 10 that can fit in there, so that would be 10. So 3D would be 10, because you can have a maximum of 3D10. Let's take a look at the next one. We're in the fourth energy level. We're in the P block because the L is equal to 1. Now, it's telling us that we're in the -1 suborbital. And it tells us that we're looking at the downspin. So, looking at our boxes here, 0, -1, and +1. How many electrons can be there? Well, we've got our downspin, so we can have upspin, 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 downspin. So the maximum number of electrons we can have in that is equal to 2. Oh, I'm sorry, back up. It's asking me what's the maximum number of electrons with each of the following quantum numbers. That negative spin, there's only one of them that's identified with that. So there's only one electron that's identified with that. There are 2 in that suborbital, but there's only one electron that has those quantum numbers. Last one. I'm getting tired too. All right, so we're in the 5th energy level. And our L is telling us that we are in the S block. And it tells us that our M sub 0 is equal to, or ML is equal to +1. Well, in an S block, we only have one orbital, and that orbital is a 0. So that can't exist. So the number of electrons that are in that orbital, none. It can't exist. Can't do it? Nope. So there are your final answers for this. Dun-ta-da! Go have a candy bar. You did a good job.